All right, let's dive deep. And I mean that literally. We're about to explore the absolutely incredible ecosystems hidden just beneath the surface of our planet's water. From a single drop in a pond to the vast, dark ocean, there's a whole world down there just waiting for us.
I mean, really think about it. What's going on in there? Our journey today is going to cover it all, from the microscopic little guys that power these hidden worlds to the massive creatures roaming the abyss. So let's get into it.
So here's the plan. First, we'll cover the basic building blocks of all aquatic life. Then, we're going to take a tour of the freshwater world, checking out lakes and some of the threats they're facing. And finally, we'll plunge into the mighty marine realm, exploring the ocean from its sunny surface right down to the deepest, darkest zones.
Okay, so before we can jump into any specific river or ocean, we've got to understand the fundamental ingredients. You know, the universal recipe for what makes life underwater even possible.
When you get right down to it, life in the water really depends on three key things. How salty is it? How much oxygen is in there? And how much sunlight can get through? The answers to those three questions pretty much determine everything about what can survive and thrive in any body of water.
And that brings us to the unsung heroes of the aquatic world, phytoplankton. Seriously, think of these things as microscopic floating forests. They use photosynthesis to create energy, which makes them the absolute base of the food web. And get this, they also produce most of the oxygen in these ecosystems. Incredible.
Okay, so with those basics in mind, let's head to our first major environment, the world of freshwater. And here, the biggest difference really comes down to one simple question. Is the water moving, or is it just standing still?
And that one simple difference creates two totally different kinds of places. On one side, you've got your rivers and streams, these really dynamic ecosystems where life has to be tough enough to handle a constant current. And on the other, you've got the calm of lakes and ponds, which are much more stable and organized into different zones.
You know, life in flowing water has to be pretty tough. The speed of that current decides who gets to live where. So in cold, fast-moving rivers, you'll find specialists like trout. Slower streams, that's better for carp. And then you have all the things clinging to the riverbed for dear life, like algae, flatworms, and insect larvae, all perfectly adapted to just hold on tight.
All right, let's step out of that current for a minute and turn our attention to the still bodies of water. We're going to look at how lakes and ponds are structured and, maybe more importantly, the threats that can just completely mess up their delicate balance.
Now here's a super important point. A lake isn't just one big tub of water. No way. Life is actually highly organized into these distinct zones, especially when you start looking from the sunny surface down to the dark, dark bottom. So the two big neighborhoods are the limnitic and the benthic zones. The limnitic zone is that open, sunlit water where you find the phytoplankton, the little zooplankton that eat them, and of course the fish that eat them both. Then you have the benthic zone. That's the bottom, the lake floor, which is home to a whole different community of bottom dwellers. And there's a cool word for all that life down on the bottom, benthos. This is your catch-all term for everything from the rooted water plants you see near the shore to critters like mussels, worms, and crayfish that are making their homes right in the mud on the lake floor.
But here's the thing. This beautifully organized system, with its different zones and communities, well, it's incredibly sensitive. And that balance can be easily and sometimes disastrously broken.
And one of the biggest threats out there has this really sciencey name, eutrophication. Basically, this is what happens when a lake or pond gets flooded with way too many nutrients, especially nitrogen and phosphorus. And where does all that stuff come from? Well, a lot of it comes from us, from things like wastewater runoff and even the detergents we use every single day.
And once those nutrients get in, it kicks off this devastating chain reaction. First, the nutrients cause a massive, super fast growth of algae. We call that an algal bloom. But then, when all that algae eventually dies and starts to decompose, that process literally sucks all the dissolved oxygen out of the water. With no oxygen, the water quality tanks and other organisms start to die off, basically turning a living lake into a dead zone. It's a really bad scene.
Okay, time to scale up. We're leaving the freshwater behind and heading out into the vast, salty expanse of the ocean, the single largest ecosystem on our entire planet.
And hey, you might notice a familiar idea here. Just like lakes, the ocean is split into a benthic zone, that's the seafloor, and a pelagic zone, the open water above it. The difference, of course, is just the mind-boggling scale. The benthic zone in the ocean can stretch from a sandy beach all the way down into the deepest trenches on Earth.
And what about where those freshwater rivers we just talked about finally meet the ocean?
Well, you get a really special ecosystem called an estuary. This unique mix of fresh and salt water creates an incredibly diverse and productive environment. In fact, they're so important that they're often called fish nurseries because they're essential breeding grounds for countless marine species.
All right, for the final leg of our journey, we're taking a vertical dive. We're going to travel from the bright, sunlit surface of the ocean all the way down, down, down into the dark, mysterious abyss.
So up here in the top part of the pelagic zone where the sunlight can still reach, life is just everywhere. You've got your phytoplankton and zooplankton, countless kinds of fish, marine mammals like seals and whales, and invertebrates like squid, octopus, shrimp, and crabs. It is a bustling, thriving city of life.
But as we go deeper, the light starts to fade, the pressure builds, and the temperature drops. And down here in the forever darkness, life doesn't just stop. Oh no, it just gets, well, it gets weirder and way more wonderful.
I mean, survival in the deep sea is all about adaptation. These creatures have evolved under insane pressure and in total darkness, which has led to some truly unique body shapes and ways of eating that seem almost alien to us up here on the surface.
And all of this just goes to show you that the diversity of life in the ocean is this complex dance of so many factors. It's not just about light. It's a combination of temperature, pressure, saltiness, currents, and even dissolved gases. All these pieces weave together to create this rich, incredible tapestry of life. And that brings us to the most important point of all. All of these ecosystems, from the tiniest little stream to the deepest ocean trench, they're all connected. What we dump into a river can eventually find its way to an estuary and out into the vast ocean. Which really leaves us with a critical question to think about. Knowing how connected it all is, how can we be better stewards of this incredible, shared, and very fragile underwater world?